8th graders, it's Mrs. Thompson. We are doing yet another video lesson on section 6.3 this time. And today's focus is going to be on example 1. We're going to find the degree of a monomial. Now some of you are probably wondering, what in the world is a monomial? Well, let's look up here. And I actually wrote it out for you, gave you a definition so you would understand the parameters of what is considered a monomial. Now, you can see hopefully the root word here, mono. Mono typically just means one. So we are talking about a monomial is just a single term, one term that's there. Now, just as a background, terms, you know the difference between one term and another because terms are separated by addition and subtraction signs. So when you have more than one term, more than one monomial, then you will know when one monomial ends and another one begins because you will see a plus or minus sign. So for example, if I had x plus 7, this is a monomial, the x is a monomial, and so is the 7. So there's two monomials there. There are two terms there. Okay, so a monomial is just, it can be a number, any number. It could be a single variable. It could be the product. Remember, that's multiplication, the multiplication of a number and one or more variables, okay, that have whole number exponents, not negative exponents or fractional exponents, whole number exponents. So whole number exponents are 0, 1, 2, 3, not decimals, not fractions, not negative numbers, nothing like that, just whole numbers starting with 0, 1, 2, 3. Okay, so now what we're going to find out today, example 1 is all about finding the degree of a monomial. That's our goal, is to learn how to do that. Well, here's the definition right there. The degree of a monomial, what you do is you add, you find the sum of the exponents of the variables. The variables, you hone in on the variables, whatever their exponents are, add them up. If you have more than one variable, add the exponents of those variables up and you have the degree. And we'll find out, well, why is that important? That will become important as we do more examples. Today, right now, we're just focusing on example 1. I just want to teach you how to actually calculate it. Now, here's a little hint. Constant numbers, now remember, constant numbers are numbers that don't have variables, okay? So they're just plain old numbers. Constant numbers always have a degree of 0, okay? All right, so let's go down here to letter A. Here's our monomial, negative 2a squared b to the 4th. To find the degree, focus in only on the variables. Well, what's the exponent on A? 2. What's the exponent on B? 4. Add those up. The degree is 6. Okay? Let's go to letter B. Go to the right here. Letter B. It's not got any variables. This is a constant number. Remember what I told you about constant numbers. They have a degree of 0. You're exactly right. Hey, let's make a little smiley face. There you go. Let's look at C. 8y is a monomial. Y is our variable. What's the exponent on it? Because I don't see it. So what is it when you don't see an exponent? Now hopefully you said 1, and so that's the degree of that particular monomial. It's a 1. Let's look down here at D. We've got 1.5 k squared m. Focus on the variables. K has an exponent of 2. M has an understood exponent of 1. That means the degree is 3. Let's look at letter E, 4x. Focus in on the x. Remember, our degree is based on the variable, not on the number, not on the constant number in front of it or the coefficient in front of it, just on the variable. What's the exponent on the x? It's an understood 1. So again, this has a degree of 1. And finally, let's look at F. We've got 2c to the 3rd power. Focus in on the variable. The variable has an exponent of 3 and that's the degree of that particular monomial. So as we're wrapping it up here, just remember a monomial, it can be any number, it can be a variable, it could be the product of a number and one or more variables. But remember, the exponents have to be whole numbers. Hey, let's underline that like 5 times, okay? So whole numbers, starting with 0, 0, 1, 2, 3. Can't be fractions, can't be decimals, can't be negative. It has to be a whole number. And the degree of a monomial, remember, we're adding up the exponents on the variable. So if there's one variable there, then the exponent is the degree. If there's more than one variable there, add up the exponents and you have the degree. And constant numbers have a degree of 0. Okay, bonus time, bonus time. Somewhere on your notes, not crammed in, you might even want to do this on a separate sheet of paper. What are the 3 exponent rules we learned in the last section? Write out those rules, and I will check those tomorrow and give you some extra credit for that. Okay, guys, thanks for listening. Great job today.